get right into it. Yes, we can record all of this. Yeah, so in the public debate recently, people have talked about very large merger cases and in general about rising market concentration and what might be causes and effects of that development. So in terms of these very large merger cases, some of them have actually been in the agrochemical industry, and you might have heard about them. So for example, there was this Dow-DuPont merger case, where in 2015, the Washington Post called it a jaw-dropping mega deal, or the Bayer-Monsanto merger case a little bit more recently, where the New York Times was discussing about whether this follows a general trend of increasing concentration and raising worries for farmers. And these kind of things have been litigated by the competition authorities, and there has been a debate about whether this is a problem for innovation and how all these kind of things work. And in this context is where I see this paper as well. So let me very briefly talk a bit about competition, innovation, and mergers as well. So when you're thinking about mergers and innovation, then you're always thinking about the trade-off between, first of all, the disincentive from a change in competition. So competition goes down, which might lead companies to innovate less and to raise prices. And at the same time, companies are always claiming that there are merger efficiencies, so that, for example, you don't need to duplicate research anymore. You can apply research to a larger scale, and therefore innovation incentives might increase. And in this conflict, the competition authorities always have to discuss about whether a particular merger should go through or not. However, when you think about this empirically, it's actually very difficult to evaluate these kind of policy decisions, because as is very well known, there's this very strong endogeneity of competition and economic outcomes, in particular innovation. So if a firm is successfully innovating, it's going to grow large and it's going to increase concentration in the sector. And if a firm fails to innovate, it might shrink and other firms might grow. And so these things are naturally interconnected in a way that makes it very difficult to run studies here. And this is even worse in the case of merger events, because there basically firms take the decision to merge, and so naturally this has to be selective, and the antitrust authorities try to predict what's going to happen, and contingent on that take the decision to let the merger go through or to have divestments or any other kind of compensation mechanism. And so that's also additional selection that's coming in. And as a result, the folks that have tried to study that, they also find mixed empirical evidence, either finding null effects from mergers on innovation or finding negative effects from mergers on innovation. So the whole picture is quite murky, and the empirical challenges are large. And so what I was thinking when I heard about this EG Farben case and this breakup is that this might be a very interesting and valuable empirical setting, and I'll try in the course of this presentation to convince you about that. And more generally, you could think of breakups as a remedy of last resort, so to say. So if everything else has failed, then maybe the regulator needs to swoop in and actually try to reorganize the market by itself. But yeah, and we can discuss to what extent this case here, in addition to the very well-known AT&T breakup, for example, can provide some evidence about this. But now let me talk about EG Farben. So very, very briefly, EG Farben was, in its heyday, the largest chemical firm in the world, definitely the largest firm in Europe. It was a major innovator. So, for example, scientists of the firm received Nobel Prizes for the world's first antibiotics that was commercially successful, which is, of course, a really big deal, and high-pressure chemistry as well. And so these technologies that were developed by scientists or firms that became EG Farben, this is basically what all of modern agriculture is nowadays relying on. So this is like, it hardly could be a bigger deal in terms of innovations. At the same time, this company controls the markets for synthetic fuel and synthetic rubber, and also of explosives. And this already brings us to the fact that this company was really, really important for the German war effort. So these synthetic fuel plants that were designed and built by this company is basically what kept the planes flying and the tanks running and so on. And so the political component here is just very big. And at the same time, the company was involved in major wartime crimes. So the history of Auschwitz, the concentration camp, is very closely connected to a plant that EG Farben was building right there. And as a consequence of that, the company was tightly in the crosshairs of the Allies after they occupied Germany. And because of all of these things, the Allies, when they come into Germany, they consider IG Farben to be just too powerful to exist, and they start this process of breaking it up. The Cold War happens, and a lot of political problems come up, and so the breakup actually happens only in the early 1950s, which is nice because it gives us a bit of a window to distinguish the time of the war and the time of the breakup. And also, the breakup structure largely follows the occupation zones. And what then happens is that you have this IG Farben company, and just visually, it's getting broken up into these companies that we still know today. So we have BASF, Bayer still around. Höchst is no longer around in the form it had then. So it was merged into other companies, and I think mostly it's now part of Sanofi. And then you had a couple of smaller ones, but the three big ones are really the ones that drive everything, basically. And so what I want to contribute with studying this case is, first of all, it's a new empirical setting that I think is really interesting because you have a shock to market structure, and that's distributed over many technologies and products. The nice thing about this is that you have this breakup that is to a large extent geographically motivated and is outside of standard antitrust litigation. And so the concerns of selection that you might have in other settings are a little bit reduced here. And then what I want to do in the course of this presentation is I want to study the effects of this breakup first on competition, and then I'm going to talk about market structure, specialization, and entry. Then I'm going to very briefly talk about prices as well, because here the theoretical predictions are clear, whereas for innovation, which is going to be the main part of the presentation later, it's not really clear what should exactly happen. I'll try to talk about both the merged entity, but I think the causal design is better for aggregate effects. So this is going to be the main focus. Let's dive a little bit deeper into the history of IG Farben. IG Farben originated in a cartel of dye producers. So these companies, they were dominating the world market for dyes before the First World War, and started to increasingly become cartelized, and they bonded together, so that basically before 1925 they had a profit sharing agreement, and they had basically, which was completely legal in Germany at the time. However, they realized that this is not enough, and even in this kind of formalized legal cartel, you have hold-up problems, and you have other concerns, so that they decided that they actually needed to integrate and to merge. So in 1925, these origin companies grouped together and formed this unified corporation. So why did they do that? For example, so in this cartel, everyone could leave at any time. And so basically, if you give up integral parts of your operation, for example, your sales organization, then you might be scooped by the other ones at some point, and you're left out there, and you need to set up your sales organization again. And after this merger, they felt secure enough to say that, okay, we're going to have only one US office and not 6 US offices, which is, of course, a lot cheaper. So you have these kind of things where you would say, okay, there are efficiencies here, and they try to integrate them over time. So between 1925 and 1945, you have this continuous integration, but they do retain redundancies. So it's called, when you read the literature about this company, it's called decentralized centralization. So basically, you have a very strong role of the major plants. You have a geographically distributed R&D, but at the same time, they try to coordinate these companies. They try to remove redundancies, not always successfully, but they try to improve the structure. And yeah, they have integrated headquarters that try to take care of a lot of things. Yeah, then after the war, after 1945, when the Allies come in, they confiscate the property of the company, and they run the administration themselves. I mean, they rely to a large extent on middle management of the company itself, while they decide about what's going to happen. And this is a bit of an involved process. But by 1952, it's decided and executed that there are going to be 12 official successor companies, in particular the 3 large ones that we talked about. To quote a historian that has studied this process quite in detail, he writes, although the final outcome of the breakup was not predictable in 1945, zonal policies helped prejudice its general contours. Practically speaking, the major Western success of the IG Farben were going to be the 3 large work units. That's the one that we talked about, of the old firms, the central factories of which lay in different zones. And here you have a visualization of that. Basically here, this is the Bayer region. Then here, Ludwigshafen, BASF, this is in the French zone. And then Höchst, here, this is in the American zone and includes some of the factories down here as well. We have a bunch of investments of IG Farben in the Soviet zone, so the access to those is lost, and they become part of the first Soviet and then East German state administration. So they are going to drop out basically from what the Western ones have access to. Now, what can we learn about this from a statistical and economic point of view? So first of all, I'm going to start with a product level analysis, and I'm going to show you in a second what the data is that this relies on. But why, when I want to talk about innovation at the end, should I start with this product level analysis? I think this is because industry features matter quite a lot for how the competition-innovation relationship should look like. The first question that we need to clarify is, like, did the breakup actually increase product level competition? Because, I mean, you can split a company up vertically. So AT&T was a lot like that, for example. And if you have a corporate demerger, they typically also want to, so they want to do something else as well. They want to break it up in silos. But in this case here, I'm going to show you that there's a lot of like product level competition actually going on afterwards. Then if you look into the theory a little bit, so if you focus on homogeneous intermediate products, chemical substances, which the product level analysis is going to rely on to a good extent, and you think about the Cournot competition model where the number of firms increases, then very clearly this model says that the price should decrease that you find. However, the innovation actually depends on the parameters of this Cournot competition. So it's not perfectly clear, at least in this model here. And there are a bunch of interesting trade-offs that we can study with product level data. So for example, you have this increased competition from the breakup. But if this crowds out other firms, then this might counteract the breakup, and actually on a market structure level, nothing really happens. And then we wouldn't have a first stage, and that would, of course, like make the whole study a little bit less interesting. On the other hand, the concentration before might have acted as a barrier to entry, and so now crowding in might happen. And so I'm going to look at that as well. How am I going to do that? There are these product catalogs. So during the time of IG Farben, there was a organization that was basically sending surveys to all of the firms in the chemical industry and was asking them, so what are the things that you're making? And how can we reach you? So if there's a customer that wants to reach you, how could that work? And then they would collect them and they would build a really big product catalog and update these things every 3 years. And then you have a bunch of entries in there that look something like this. So you have a chemical compound here, and then you have the set of companies that are offering that one. And this is from 1952, the first post-war catalog. And here you will see that this product is supplied by Bayer and also by Höchst. So this would be a case where there is competition between IG Farben successors, and then you have some other companies that are not associated with IG Farben. And so this is going to provide a detailed and also large sample look on what the chemical industry then looked like before and after. This is the first graph that descriptively tries to approach the question of how does the product portfolio overlap between the competitors look like. So each on the x-axis here, this is in 1952, so directly after the breakup. And like 50% says that one company also offers 50% of the products of the other company. So the larger company offers 50% of the products of the smaller company. And so this gives you some kind of idea on how much this is overlapping. And then you have the same thing for 1961, so 10 years later. And with the 45-degree line, you can see some amount of dynamics here. So the first thing that you can see is that there's a relatively wide distribution of competition levels, basically between the successor companies. And this is going down to some extent over the next 10 years. But even in 1961, you still have some level of competition between the successor companies. So this looks like that the breakup actually induced competition on a product level, and it seemed to be long-lasting, although it was moderately declining. And next, I want to investigate what kind of immediate effects in this product level data this might have. So what I talked about, entry and prices as well. This here is a first regression table about entry, or like about the market structure effects, maybe more generally speaking. So here in these 4 columns, the outcome variable is going to be the number of firms, and here is going to be the number of firms that are not associated with IG Farben. And then here, the exposure variable is that, first of all, in this group here, IG Farben, one successor of IG Farben was active in the market, and here it was 2 or more successors of IG Farben that were active, and then evaluated in 1952 relative to the 1939 baseline, and here in 1961 relative to the 1939 baseline. And what you can generally see that is that, yeah, and then one column is always without many controls and the other one's with more controls. So like this setup is maybe not perfect, but it's very good at giving a first impression of what's going on here. So if you look at the non-IG Farben firms, and this is the main point here, I think, when you look at the case where one IG Farben successor was active, then you don't really see much of a difference in terms of what is happening here. But here, especially in the case where 2 or more IG Farben successors are active, you can see that the number of firms active in the market that are not associated with IG Farben is increasing quite a lot in the 10 years afterwards, and not so much or just a little bit in the short run. And this is the main takeaway for me here. So it seems that the competition was increasing in the short run, and it didn't lead to this crowding out effect in the long run. And rather, it seems like it facilitated additional entry. Now, with prices, so first when I was thinking about why to add prices to this, it was that prices are kind of the most immediate thing where you would expect some kind of effect after you have this kind of market structure shock. And no matter what I find in the innovation analysis, this will give you some kind of centering on, you know, like there is actually something going on in terms of competition, something that is plausible ideally. And so what I found is this industry journal from the German Society of Chemical Engineers, where between 1949 and 1954, they list monthly factory prices that are reported by firms. Afterwards, these reports stop, and before that, there were price controls in Germany, so that basically the price levels really don't matter so much. So I OCR these reports, and the data looks just again for the same chemical compound that we saw before, looks a little bit like this. So they give price ranges at particular dates, and sometimes you have these different quality levels. So, for example, this one here, or there's different. So slightly different types of the same compound. So this one here is a powder form, and the other one is a more generic form. All of them are ready to, so according to medical standards is what this here means. And so basically I will go through this, this list of compounds that they have, and I group them into these quality profiles. And for example, drop these ones out here where the time series is too short, because I need data before and also after the breakup. Course. Then if you do that, what comes out is this here. It's quite interesting that after the breakup in these areas where only one successor was active, relative to the group of products where IG Farben was not active at all, actually the prices seem to slightly increase. Whereas here in the for the group where multiple successors are active, the prices seem to go down a little bit. And then we can do some propensity score matching, which uses both pre-treatment prices, chemical properties, and also like the level of competition in these products. And it looks like these effects are stable, also accounting for these kind of things, and the effects actually seem to become quite a bit stronger. So this is also robust to introducing a number of control variables that are important because of the historical context. But I will group the discussion on the historical context and control variables in a section at the end. But now it's time to come to the main part, the part on innovation and patents. So first of all, Historical patent data is a bit of an issue, of course. You need to often collect the kind of things that you want yourself. The information that is available from these German patents is the technology class. And then it's very important to have like the inventors and the inventor location. And then, of course, the applicant and the applicant location and the application date as well. So these things are, especially the technology class, I had to extract myself from these patent documents. And another thing that is a bit different from typical innovation studies that you see nowadays is that in this time period, you don't have this front page patent citations that is easily available. So instead, I rely on text similarity-based patent quality measures. So doing something very similar to this paper, which is forthcoming in AR Insights. To make this really short, basically, you have text similarity to future patents, which captures something like the impactfulness of the ideas that are embodied in a particular patent. And then you have similarity to past patents, which captures something like how derivative the thing is that you're doing and how similar it is to things that have already been done. And the idea is to divide these by each other, and by that get some idea of how important relative to how derivative a particular patent is. And so these folks, they show that this correlates quite well also with patent citations. And so for this purpose, I have to make do with that. Now, the first thing I want to talk about is a descriptive analysis that is focusing on IG Farben itself. The thing with that is that I don't think I have a very good causal design for the merged entity itself, because as we talked about, there are only very few successor companies. I mean, 12 is not very large by itself, but if you think about that, the most important ones are basically 3, then statistics is going to be difficult and it's going out of the window relatively quickly. So this is just purely descriptives. And so what I'm doing here is to have some kind of synthetic control style comparison with the electronics industry in Germany, which is similar in the sense that it's a high-tech industry. It is also dominated by very large firms. It's a duopoly though, so between AEG and Siemens. And these are, in fact, in my data set, the only firms of a comparable patenting amount with IG Farben at that time. The nice thing is that the electronics industry is unaffected by breakups, but similarly affected by other occupation policies and other things that were going on at that time. And so it's an okay comparison, I would say. And yeah, what you can see is that before the war, then AEG and Siemens have a patent portfolio output that is developing relatively similar to IG Farben. And that's also true immediately after the war, but IG Farben, and at this point is of course the successors, it keeps going up, whereas for AEG and Siemens, the profile rather stays flat. So this is suggestive evidence saying that it seems that the patenting by IG Farben has increased later on, which is in line with the historical narrative of these companies being relatively successful. However, how can we study something that gives us a bit more maybe causality? And for that, I want to go to aggregate patent counts and set up a technology year panel and go to a typical difference and event study analysis. So in the regressions that follow, you will see these quality-weighted patent counts by technology class in a very standard setup. And then the really interesting part is, of course, how do we measure the exposure to the breakup of IG Farben, this variable here. And we're going to do that by using the change of the Herfindahl-Hirschman index. So this is going to be called data HHI. Between, in a static sense, IG Farben as one block, and what's the HHI of that? And then IG Farben split into separate parts, and what's the HHI of that? And first of all, the nice thing is because the rest of the economy stays constant, we only need to focus on IG Farben itself. And this is also in line with what, for example, Nocke and Winston say that is the relevant thing when analyzing these merger cases, so that you should focus on the dynamics here. And I'm going to focus on a pre-war measure to avoid contamination and avoid the dynamic effects that happen through the war and what's happening immediately. And let me maybe very briefly talk about how this works technically. So I want to have a look at the successor companies' patents, but at the time when the successors didn't exist yet, but when it was like one integrated company. And as you saw on the patent before, on the patents of IG Farben, it was written IG Farben and not Bayer or not BASF. So after the breakup, historically, this is something that I learned on this week actually when I went to the central IG Farben archive. What they did is that they redistributed the patents after the breakup, mostly according to the inventing unit, which, because of this geographical distribution, is something that I can follow as well. However, after these patents were distributed between the IG Farben successors, it was mandated that there would be royalty-free licensing among all of them, so that the distribution, the structure of the distribution itself, was of no consequence for the operation of the particular successors. But we can use this to follow the structure of the breakup before the breakup actually happened. And so how is this going to happen? Basically, I use inventor locations and also inventor careers later on, and I assign patents to the successor companies, and this is successful for a very large share of the sample. And you can see this here. So BASF patents, if you just look at the original patent document, there are no BASF patents here, and then you have some after the war. And then after the reconstruction, we can find a patent portfolio that is relatively meaningful in the historical context. Right. So this is all a lot of busy work in order to be able to measure this change before the war. And in the main regression, this delta HHI is going to be the exposure variable, but alternatively, it's also possible to focus on only within IG Farben. So basically consider IG Farben the whole universe and just say what the concentration change here is. And this removes the fact that IG Farben had a different amount of patents and different technologies. And there's the concern, of course, that these measures are going to be driven by the amount of investment of IG Farben somewhere and not by the breakup. And these here, or the focus on only the geographic variation within IG Farben, brings us closer to the idea that we want to compare similar technology classes, and the only thing that's different is the breakup and the change in concentration caused by the breakup. All of this is going to happen within technology classes that are relevant for chemistry. And here, finally, you have the first innovation results. And in this case here, for ease of understanding, this is using a binarized measure, so basically the top 25% of technology classes against the rest. And you can see that over the long pre-trend, this is relatively flat, relatively stable. Then in the wartime, you have some issues because of the historical context and also because of institutional details surrounding the German Patent Office. But afterwards, when things go somewhat back to normal, you still have a relatively flat trend, and only after the breakup has happened, you have a divergence in the technology classes that are strongly exposed to the breakup versus the ones that are not exposed or only little exposed to the breakup. And so in this case here, I'm focusing on patents that are not by IG Farben, so basically everyone else, but the results look rather similar when I focus on all patents. Then to introduce a tables format that I'm going to show you in a bit to show you more heterogeneity results. I distinguish between 3 periods. The first period is everything here between 1925 and 1944. And then I have the very brief period here between 1948 and 1951, and then between 1952 and 1960. And these are going to be grouped as coefficients, and this is going to be the baseline. And so the difference between the pre-breakup, post-war, and the post-breakup period is going to be the coefficient here. And in the table, it looks like this. So again, you have the exposure, the delta HHI measured pre-war, looking at the quality-weighted non-IG Farben patents, in this case here. And then this is the post-war pre-breakup period, and this is then the long-run post-breakup period. And here is the difference between these two coefficients. And you could think of the effect as either this one, which is relative to the pre-war baseline, or as this one, which is the difference between those two. And yeah, what you see is that, first of all, there seems to be a very large increase in the innovation here, no matter whether you have quality-weighted patents, whether you have just a raw count. And it also doesn't matter if we change the window of measurement for the concentration change. So it also works if you measure this using the post-war pre-breakup patent applications. However, what's quite interesting is that if you focus only on foreign patents, then it seems that the increase in the amount of patents is immediate. And so it doesn't seem to be strongly related to the breakup. Why I think this is why I distinguish between those two, because then I can see in this case that it seems that something about the war itself or the changing post-war structure led to more foreign entry, but it doesn't seem to be very strongly related to the IG Farben breakup itself, because there's no pre-post difference between these two coefficients. And here are some results for the delta HHI within IG Farben, and only focusing on the geography. So I'm sorry that I'm skipping actually one step here, but this is now not using the binarized version anymore, but this is showing you that this also works with a continuous version. So if you have this standardized measure here with a mean 0 and a standard deviation of 1, then you can see relatively similar patterns, that the patenting amount goes up as the change in concentration is larger. And in terms of additional results, this is something that is also quite interesting. So one thing that you could, for example, wonder about is whether you have more competition going on now in this market, and maybe it's the case that IP itself becomes more available to these companies, and this is why patenting is going up in these areas. And if that's the case, then you should see something happening to patent quality. Basically, also lower quality applications, lower quality inventions now get put into patents, and more incremental things. So basically, you should see a change in the threshold. And if you look at the data and look at the average quality now within these technology classes, you see something that is actually pretty much in line with this idea, at least in the short run. So you see that after the breakup, that the average quality of the patents that are applied for by these companies does go down, but it does normalize after some time, which is quite interesting because when you look at the raw patent counts, you see a bit of a discrete jump here, which is not really consistent with we think that innovation processes work. But with this quality weighting and this idea of that there is some short-run change in the propensity to patent, we can actually see that this is, I mean, it's consistent, and the quality-weighted one goes up more slowly than as we saw before, right? You can see something similar in the number of the average inventors, so in the average number of inventors per patent and so on. Something that's quite interesting and that I'm still working on is the aspect of technology specialization. So one thing that you're wondering when you're thinking about mergers and merger efficiencies and so on is whether there's going to be duplication of research and whether these companies are going to all do the same thing, and this is going to be wasteful. And if you look at the historical narrative, then it is the case that these companies were active in pretty similar domains. For example, in plastics, all of them developed different types of plastics, but in this case, it was not really wasteful because the properties of the different plastics that they developed were different, and so you can use them for different things. And so, although the technology similarity will look very high, it's not necessarily that it's wasteful. And on the other hand, one of the things that happened in the 1950s and especially later in the 1960s is that these companies changed from using coal as an input resource to oil as an input resource. And all of these companies did that, and they all basically, to some extent, reinvented the wheel. So I'm just saying that this is actually a complicated question that I'm still thinking about how to perfectly address that. But if you just look at the cosine similarity between the patent portfolios of the largest successors, then you can see that the specialization, so the similarity was very high even during the existence of IG Farben, to some extent it goes up maybe, but it stays on a qualitatively similar level. So these companies are all working in relatively similar technology domains before and also after. Right, and as the last point, I was promising you to talk a bit about robustness checks, because this is something that is always on your mind, of course. Like, we're talking about a period that's immediately after the Second World War, and then you have this very dynamic recovery of post-war Germany, of the IG Farben successors themselves, but you also have other things like the German separation. You have occupation policies that result in dismantling of some factories. You had the war destruction, all these kind of things. And so what I'm attempting with this is, first of all, I'm trying to make the argument that if there is a major factor that is driving all of this that is not related to the breakup and not related to the competition change, it would have to be very closely correlated in structure to how the breakup was structured. And we could see in these price regressions and these market structure regressions that the particular structure of the breakup, with how many successors there are on a particular product level, is really important. And so you would have to have a component that is very strongly correlated with this microstructure. Whereas most of these things that we're talking about here are really macro things that are affecting the whole economy and affecting all of these technologies at the same time. So to some extent, relying on this microstructure should, to a large extent, be able to extract these changes from the regression. But of course, you're not going to believe that right away. So I collect a lot of indicators with whom I try to capture as many as I can of these historical factors. So let's maybe very quickly go into that. So this is the technology class level regression that you saw before. And then I have a bunch of different control specifications where, for example, I exclude plastics, which was particularly focused by the post-war occupation policies. Here I have a indicator for how much the technology area was affected by dismantlements, where I digitized some historical sources for that. You can control for how much exposure this technology class had to East Germany and Berlin, which were quite heavily affected through the separation of Germany. This here tries to control for war destruction, and taking everything together, you see that the results, they move around a little bit, but not to the extent that we should be majorly worried about these factors. You can do that both on this technology class level regression, you can do it in the firm level regression, and you can also introduce these types of control variables in products and these price level regressions. Some of these things are actually enabled just by having these prices. But overall, I'm just saying I try to check as many boxes in this regard as I can. And for the other ones, I try to discuss the historical narratives in the paper. So if you're interested, ask about it in the discussion, I think. But to conclude, in this paper, I tried to study the effect and the success of this intervention, the breakup of IG Farben. It seems that this breakup created product market competition that was long-lasting, although moderately declining. We had a price reduction in chemical commodities, and it seemed that actually entry was facilitated through this breakup. And in particular, we had a large increase in patenting in the affected technologies. In terms of policy implications, this is definitely saying that competition seems to have been very good in the post-war German economy, and it makes the case to have a strong antitrust regime in place. And maybe this can serve as a starting point about thinking about whether breakups as a very rare policy tool might be useful. But of course, in applying this to today's cases and generalizing this, we need to be careful for many reasons. And with that, thank you very much for listening. I think we're right on time here, and I'm looking forward to the discussion.